Hello, my name is Micah Swann, reporting to you from Lago Yanquihue, Chile. I'm a PhD candidate at UC Davis in the Department of Civil and Environmental Engineering, advised by Dr. Jeff Schladow. I conduct applied research using high-frequency measurements of temperature and dissolved oxygen in conjunction with numerical modeling to understand how development and climate change impact lakes across the trophic spectrum, from California to Patagonia. Today, I'll be talking about the monitoring and modeling program that I've been leading in collaboration with the Chilean lake advocacy NGO, Fundación Chile Lagos Limpios, to inform sustainable development in the northern Patagonian lakes. Dissolved oxygen is perhaps the most fundamental indicator of the health of an aquatic system. And over the last 50 years, the concentration of oxygen in lakes globally has been declining. This deterioration has been driven both due to cultural eutrophication from watershed development and climate change. I say globally in quotes because while changes in the northern hemisphere lakes have been well documented, the changing conditions of lakes in the southern hemisphere remain poorly understood due to the lack of long-term monitoring. To fill this knowledge gap, my current PhD research is focused on the 23 lakes of northern Patagonia, a region globally recognized for its unparalleled beauty and its pristine glacially fed lakes. However, these lakes are becoming increasingly stressed due to regional population growth and associated demand for development. While development is necessary to provide employment and create new opportunities, it is occurring in the absence of an understanding of the interactive effects of land use and climate change impacts on lake water quality. In order to proactively support sustainable development, for my research, I've established a monitoring and modeling program for Lago Yanquihue, the largest lake in the region, in order to better understand the lake's current conditions and how it may change under future land use and climate change scenarios. To investigate the dominant physical transport and mixing processes that pervade in Yanquihue, this past August, we deployed 3 monitoring buoys equipped with a vertical array of temperature and DO sensors spanning the full depth of the water column and a meteorological station at the surface. Together, these instrumental arrays provide a window into how changing wind patterns at the lake's surface drive internal movements of water and oxygen throughout the lake. Using the data collected over the past 6 months, I've calibrated a 3-dimensional hydrodynamic model, which uses inputs of the lake's bathymetry, the shape of the lake's basin to define the model domain, meteorological data as boundary conditions for heat and momentum inputs to the lake's surface, and temperature profiles from our monitoring buoys as initial conditions. The model can then be run forward in time to simulate the mixing and transport of constituents across the full spatial extent of the lake. To show a use case for this model, we recently presented a demonstration to local stakeholders of how we could simulate the transport of contaminants released from urban areas if proper environmental regulations were not in place. Over the span of a few weeks, traces of this contaminant spread out through much of the lake interior and impacted almost the entire lake shoreline. The following day, results of this demonstration were on the front page of the local newspaper, highlighting the intense interest of the community in this research. With this physical model now calibrated and validated, I'm working towards coupling it with an oxygen model to simulate the sources and sinks of DO in this lake. Once complete, I will conduct a sensitivity analysis to evaluate the potential physical and water quality effects of a warmer climate and examine how Yanquihue may change over the course of the 21st century. Thank you to the ARCS Foundation for your support. Your generosity has allowed me to pursue my passion of protecting lakes for future generations to come.